Bitcoin mining. And I think that's really the future of Bitcoin mining is when we have the opportunity to use new resources, use innovation, we're going to be able to uh, reach new heights by uh, innovating new things. You know, there's ways to make Bitcoin without connecting to the grid and paying a lot of money. There's ways to make it more profitable. When you look at some of the free energy that you can get, no energy is free, but when energy becomes a renewable source like a flare gas or a solar or something like that, the cost per kilowatt is so low, it's below 3 cents. Um, when you are in a bear cycle like we are right now, when things aren't going that good and the price of Bitcoin's a little bit lower and none of my meters are up, but when it is low like this and you look at the cost of the Bitcoin miner, you look at the hash rate and the difficulty and all of the things combined, it's very profitable to be a Bitcoin miner with these renewable energy resources. So we're going to have a great show for you today. We're going to play a short little video and then we're going to get started.
One of the biggest problems in the environment.
Okay, that was just a little test to see if you were ready. But now that we're really ready, now we're going to turn on the sound and actually play it. Okay, now we're good. Now we're good.
There's so many tires, and we're trying to address that tire problem with a very unique solution that turns those tires into an electricity source.
This works for this coffee cup right here. It's just a different yield. It's something that should be available to everyone, and obviously to the Bitcoin blockchain for an energy source.
The Bitcoin mining process actually generates heat for which we can dry the plastics before they go into the vessel. Plastics or the tires that go into the vessel create diesel. The diesel goes into the barge and it fuels the barge. The propane that's released from those materials then fires up the generator. Actually, the end result is Bitcoin. It becomes a perpetual motion machine that's fed by Bitcoin.
We have these resources we've already stripped the precious world of and have done a terrible job in making something that is sustainable and closed loop to make sense. You know, when you see pollution and you see different things going on, it's quite disturbing to see, you know, how many microplastics exist in these fish and everything else. We can use what already exists as opposed to taking something new or taking something away from someone else. You know, it's a great opportunity for that.
I'm Dan Kaler. I am Chief Mining Officer for Kratos Digital Mining, and we are the mining branch of Trend Discovery, who does a lot in renewable energy projects. So this is a very unique process, and it's a phenomenal idea, and we're here to put it into prototype scale and get real actionable results so that we can start taking it large scale and getting creative, looking at options for stranded gas that gas head owners are still having to pay to maintain. We can go in there and help them consume and streamline their operation while monetizing the gas that they can't do anything with and stabilizing the blockchain and creating jobs. And most people just don't know that this type of process even exists.
We believe if we can address this tire issue, not only does it address landfill and waste, but it also creates an electricity stream that can fulfill the needs of our growing electrical demand in this country.
My name is Adam Broston, and I'm a third generation in auto recycling. This was something that my grandfather had started working on quite some time ago. When he got out of the war, he tried to see, you know, how many tires he could get because he wanted to be able to sell them. Towards the end of his life, we mainly talked about how to get rid of tires. The need at this point is how do we deal with these tires, which was still the same need I was speaking with my grandpa about, you know, throughout his life. We're paying disposal fee to get rid of these tires, but it's not like it's being recycled. They're cherry picking the steel and then the can gets kicked down the road. This breaks things back down to original byproducts, and it does it in a manner that is sustainable and at a lower temperature parameter.
The process here is pretty simple. We take our feedstock, and whether that's produced yourself or brought in, it's just tire shreds. Stainless steel taken out. You take your tire shreds, and we come in and we load up this hopper here. When the machine is running, it's going to be operating this conveyor to bring it up to the top of the canister and drop it in sequence as programmed and as the machine is requiring the new inputs. Once it drops into the canister, it's going to start the process of separating all the base materials into the offputs and essentially run through a series of these valves and tubes and separate your different materials. So your industrial rubber product is going to be coming down out of that bottom spigot and run through the pumps and get offput into barrels or a tank to be taken away with a truck. Some of your other materials like the vaporous gases are going to be coming out up here. Some of your diesel fuel is going to be coming out and run through the pumps, the compressors, the cooling units to become a usable byproduct. As we come over here, we can show you what some of this clean industrial rubber offtake looks like. That is just a pure reusable rubber product out of the tires. The gases that come out in the aerosolized state, they'll run through the condenser, they'll cool off, and then come down into the liquid separator where you will have your diesel mixture and your gas mixture run through a series of pipes, and then we come outside of the building here. So through these pipes here, you get your gas flow. The aerosolized gas is going to come through the compressor unit that then can go into the propane tank. And from that propane tank, it's going to connect to one of the generators in the back and start generating power. This entire facility will be able to run on the aerosolized gas output, as well as running our small little test Bitcoin mine here. If you focus on just tires, you get the recycled steel, you get the aerosolized gas, the diesel gas, and the rubber. So you get all four elements from tires themselves, and that has substantial opportunity for power generation. At that point, the only output that you have as far as a waste or environmental impact is what your generator puts off. And there are so many very efficient, carbon effective, and filtered generators now that that's negligible output. And when you can start generating megawatts to hundreds of megawatts of power off of garbage that people are having to store in landfills or dump in the ocean, we can save all of that.
This works for this coffee cup right here. It's just a different yield. You don't receive a rubber, you get an off gas and a lighter sweet crude. By doing this with tires, we're solving a major issue, but that also will allow us to generate the ability to go out and focus on these other issues that exist, such as the great garbage patch of plastic and different things such as that, where you could have belt-fed conveyors on a tanker vessel and be doing this process at sea in a confined space and cleaning things up. We're trying to make things right the best we can. So, and this takes a lot of different people and a lot of different perspectives to make that happen. So that's one thing that we have been truly blessed with, in having the ability to have some really, really bright people work on this, because it's something that should be available to everyone, and obviously to the Bitcoin blockchain for an energy source.
The Bitcoin mining process actually generates heat for which we can dry the plastics before they go into the vessel. Plastics, or the tires that go into the vessel, create diesel. The diesel goes into the barge and it fuels the barge. The propane that's released from those materials then fires up the generator. And all of that closed loop positive creation economy, actually the end result is Bitcoin, right? And that Bitcoin can be liquidated and pay to continue to flow this feedstock inbound into our process. Once we have the machine running from the feedstocks we collected, it becomes a perpetual motion machine that's fed by Bitcoin, right?
I want to see this project reduce energy costs, reduce emissions, and landfill waste, and what we deem is a no longer viable or valuable offput. We've got so much garbage in this world that doesn't need to be there. It can be mitigated, and we can cleanly and effectively utilize it to power this next generation. I know a lot of politicians are out there and they're of the mindset that consuming energy is bad. And I don't believe that. Producing energy in the most positive, effective, economically and environmentally viable way is the path forward.
All right, so that was fantastic. That's Dan Kaler, and he is a visionary entrepreneur and seasoned crypto executive with expensive and extensive crypto executive expertise in the mining operations, equipment and procurement, and mining development. John Taylor did not go to speech therapy today, and apparently it is not working out very well for me. So, as the founder and president of ASIC Plug, also known as ASIC Wholesale, he leads a premier US-based crypto mining equipment procurement, brokerage, and consulting firm that delivers cutting-edge solutions to digital asset miners. With a strong foundation in IT engineering and a proven track record, including his role as Chief Mining Officer at Kratos Digital Mining, Dan combines technical prowess with strategic insight to drive innovation and operational efficiency in the crypto mining space. His deep industry knowledge and entrepreneurial spirit make him a trusted authority in optimizing and scaling mining operations. And with that, we will welcome to the stage Dan Kaler from Kratos, and we're going to talk about renewable energy, and we're going to just move him right to the webinar. I'll just do it. Okay, we'll do it again. There we go.
Excellent.
This is fantastic. You have a lot of Bitcoin stuff behind you. You go to all the conventions, don't you?
Anyone that I can, schedule wise, it's not always the easiest to make it out to all of them. This coming Disrupt, I have an obligation, but I'm sending my right hand helper Carla. She is going to be down there representing our group. And it's been exciting. I've been spending a lot of time on the job site that you guys showed with the tire reactor there, and working really heavily to get that prototype configured and ready to bring to market.
Yeah, that's an exciting project. I know we're going to have Trevor on the call here in a little bit because we're going to ask a lot of questions about renewable energy. But, talk about I know that you work with larger companies in the Bitcoin space, but where does that innovation lie? How can these renewable resources be used to make Bitcoin for the small entrepreneur who wants to get into the business?
Right. Yeah. So a lot of the areas where I consult in that space are people that maybe have gas wells on their land, out in West Texas or Pennsylvania or places where the old family farm has a little bit of gas. They're not an institutional gas well. They're not something, that was drilled by Chevron in the 80s, but they've got a little bit of gas flow that comes through, but maybe it's not enough to really justify having it pipelined or having it brought out somewhere else. So they have to just kind of maintain the wellhead, cap it and endure the expense of making sure it doesn't leak, and they can't really monetize or only very minusculely monetize it. Whereas something like, blockchain tech allows them to set up a small little generator. You can do 100 or 200 kilowatts and run off of a flare gas or a small stranded gas well and be highly profitable because you're consuming your own gas, you have your own capital investment, you own all the equipment and everything in place. So I've consulted with a number of groups on that. Consulted with a number of people that are looking to get into flare gas. And then, of course, with this tire project, that is just absolutely groundbreaking technology. There's nothing else like this in the world. In fact, I've spoken with a couple of chemical engineers like, oh, no, what you're saying isn't possible. I'm like, yeah, it is. Oh, no, physics says it's not possible. I'm like, you want to come see it? Like, we're doing this. It's pretty cool. So, finding just the secret sauce of making that happen has been incredible, and that will allow people, either miners or people that just need to generate the power for their own, say, remote villages or things along those lines, to be able to generate power for everything from garbage, and that is what is absolutely incredible. And John, I think you're still muted.
I had apparently Amazon or someone came to the door and my dog greeted it with many barks, and she's still at it. So, anyways, um, the opportunity that I saw when you showed us the tire ingester that we just saw the video on, and then he started talking about, we could clean up the ocean and
Yeah.
we could do all these things. So those are big dreams. Those are down the road. There's technology that has to be invented and created to do that. But the idea of that is that, there's a lot of opportunity there to do big things to change the world. And I'm going to mute again.
Yeah. Yeah, there absolutely is. There's huge potential and huge opportunity. And the technology that we have, we've cracked the code. Now it's a matter of what vessel size, what pipe, what tools are the best implemented to use that code to be most effective and efficient. And you're right. This, as Adam mentioned in the video, this could be something you put on a container ship and sail around the oceans. It's also something that you can set up near ports. So people start, collecting garbage as they come through, or third world countries. There's a lot of Caribbean nations where their entire country's power supply comes by bringing in tanker ships of diesel. And that's immensely expensive for electricity. And if you set something like this up where they can start, molecularly deconstructing their own plastics and tires and create their own fuels to generate their own powers on the island, you can reduce electricity costs. And it's absolutely incredible, the potential of this project, even outside of just the blockchain and the financial tech space. It literally is a solution to the world's energy problem.
I really appreciate that. So I think Trevor has a question for you real quick.
Yeah, I
Yeah.
mean, Dan, I want to know like what inspired you to get involved in this space? You've done a lot of different things. You've been
Mhm.
involved in mining operations, but what specifically got you like inspired to build like energy production through tire breakdown?
Yeah, so that's funny story. As I mentioned, I'm involved with Trend Discovery, and it was a little over a year ago. I got an email across my desk that said, "Hey, here's a couple of contacts, connections we have, opportunities that have been pitched. Take a look at some of the info here and see what might be worth looking into." And as I was digging through the slide decks and looking at, boring corporate stuff, I saw this. I'm like, that can't be real. So I dig into it. I'm like, that's some interesting looking stuff. And I said, we need to put some effort, some resources into this. I need to fly out to the super secret lab location, take a look at stuff. And they said, yeah, we'll go out there and have them fire it up. And I get out there, like, we're in early configuration stage. We've done some minor testing, but it works. This is how we know it works. This is what we've done to prove it. We need um, we need some help getting everything to the finish line. So that's where, myself and Trend Discovery, you saw Brad in the video as well. He's the founder of Trend. We came in and said, awesome, this is going to change the world, and we're not going to let it, sit on the wayside. What do we have to do to make this change the world? And that's what we've been pushing forward over the past year and made incredible progress. I was up there just a couple weeks ago doing some small scale testing with, additional catalyst components, and it was just so amazing to be hands on with this stuff. Running the machine to drop the tire shots in, or grinding the plastics to do testing on the plastic side, just to see that this was garbage that would sit in a landfill for hundreds of years and take up space and pollute the earth and pollute the soil. And now I'm turning it into fuel to fuel the world. It is just, it's a feel good situation.
Yeah, I really love what is happening here. And I think about the future of, not just Bitcoin and mining, but also like the future of the world and how we actually recycle things. There's this whole idea behind recycling that like it's not very efficient, it's very wasteful, like we don't actually recycle things the way that they are advertised. And what I think is so innovative and great about this process is you are actually recycling plastics and rubbers into something that is highly useful, and
Mhm.
it's you know, it goes so far as to be helpful for small nations and large nations. It doesn't matter where you are in the world. You can set one of these tire digesters up and start mining Bitcoin, or even just producing power for a small village or whatever.
Right.
But I want to dive into the process of how these tires are broken down and converted into usable energy. Obviously, you can't share any proprietary information, so you
Yeah.
can't share with us what the catalyst is or anything like that. But just kind of walk us through this process in depth, how it works.
Yeah, absolutely. So, depending on what phase of the plant or the processing center you're working in, you can either have pre-shredded tires, brought to you by super sacks of the stuff, or get the raw tire and shred it yourself. You take the steel out, and once you have your tire shreds, the components that go into it are largely petroleum based. Tires are mostly made from rubber and oil. So because of that, they will drop into the canister that we saw in the video, or similar models that we build at larger scale, and the mixture of the secret catalyst and the right operating temperatures in time will, what I refer to it as molecular deconstruction. It's also been referred to as digestion, but it separates all the base elements. So in doing so, you have your, at temperature, your gases that come off, and then your liquid rubber that doesn't separate out into a gas drips down to the bottom. So in that process, when you're done, or periodically or whatever, based on your volume time cycle wise, you pump rubber out the bottom. And that's what in the video we showed, that green barrel of the liquid rubber. And then the gases float up through the catalyst to the top, and they go through the condenser, which cools the gas. And that's how you get your condensables that we've dubbed diesel. It's a mixture of a couple of different carbon chain fuels, but it is ultimately a diesel product. And then you have your non-condensables, which we've dubbed, propane, which is a mixture of a couple of carbon chain vaporized gases that run through the compressor and then into the propane tank that you can also feed to a generator. So in the video, we showed that generator behind us. It was nothing special. It was a rental right off the yard. We hooked it up for propane intake. Our fuels ran it beautifully. We had enough power generation to run the facility, and I think we had 22 Watts miners running in that upstream data hash hut on site. So we were processing tires, stockpiling the diesel. We didn't even burn the diesel, and we were consuming the propane that we were creating while mining, running the site. I mean, it truly was perpetual motion, and creating the rubber. And that rubber has a lot of industrial utilization as well for enterprise roofing projects. It can be mixed into and turned into asphalt. So, reintroduce it into an asphalt plant, and you've got a lot of the base there. So it really is consuming every step of, this process, consuming every element from this process, whereas so much recycling is, incineration and waste, or yes, we're going to recycle this computer, and they melt the motherboard to get the rare metals, and everything else is just garbage and goes to a landfill, and they call it recycled. No, this is truly every single piece that comes out is utilized. There's no garbage char. It's not pyrolysis where you get chemicals and toxins and all kinds of goo. It's a clean recycling process. It's absolutely incredible.
That's great. I love how the process is working. Can you tell me a little bit about other recycling processes that you've seen or that you're maybe experimenting with that may show promise here in the future?
Yeah, so the plastic side of things that we're working on, in addition to the tires, is really exciting as well. Most types of plastics can be recyclable, and they go through the same process, and they turn into the off gas that becomes diesel and propane. You don't get the rubber from it because it's not rubber, it's plastics. But Very, very similar situation, a little bit different form factor for the components, but we can do things like that. And then there are other recycling groups out there not affiliated with me, and I wouldn't, call myself an expert, but there are other people trying to accomplish the same types of goals through things like pyrolysis or breaking down components either through incineration to create energy or cleanly reusing the products. There's some really innovative stuff coming out of third world countries these days, which is incredible because they have a surplus of other countries' garbage, unfortunately. European countries will just kick the can down the road and throw all their stuff into these other nations. And well, they're trying to find a way to turn that garbage into a commodity with unique recycling projects.
Yeah, the next question that I have, we talk about recycling, we talk about all the other waste disposal methods. What are the emission concerns, if any, around this process, and how does that kind of compare to other waste disposal methods?
Yeah, so compared to other waste disposal methods, this is phenomenally clean. The only real emissions that you get is whatever generator you're using to run your fuels. Now, we have partners with major generator companies. There are carbon scrubbers that you can bolt on. There are ways to reduce your generator emissions between 70 and 99%. So you can make it pretty much a net zero. When you reduce 99% of your generator emissions, you're essentially operating with zero influx. I mean, it's less emissions than you get from running your car for an hour, kind of thing. It's absolutely incredible when you're looking at the numbers. So this is the cleanest way to dispose of tires that exists. Period. Like there's nothing else out there. They always, a lot of places will shred them and reuse them, but that doesn't get rid of them. Shredding them and putting them on the ground in the playground doesn't get rid of that. And there was a recent study that 78% of microplastics inside the human body come from tires. And that's
Really?
because when you're hitting your brakes, when you're driving around, it's aerosolizing everywhere we are because there's cars everywhere that we are. And that, I believe it was a Yale study that came out recently, and that was just mind blowing seeing those figures.
Yeah, that's I didn't know that. That's wild to think about, actually. Yeah, no, it's definitely interesting because you're talking about, recycling versus actually just getting rid of altogether. But then you also have the rubber like product from this
Mhm.
disposal process that can be reused in other processes. So instead of having to recreate new rubbers, you can just use the old rubbers for new processes.
Right. Yeah, and we are in the process of discussing with tire manufacturers as well. Because of the safety concerns, they haven't just said, oh, yes, give this to us, we'll start making tires from it. But that is going to be tested. Can this rubber be turned back into tires safely? Right now, they, aren't going to just change the process, but there are plenty of use cases from, asphalt to roofing to any number of other operations that this stuff can be used for effectively.
Hmm. Yeah, it makes a lot of sense. I mean, why couldn't you turn it back into tires at the end of the day?
Yeah.
It I don't see why it wouldn't work. How scalable is this technology? I mean, could similar facilities be set up in other countries? I mean, you talked about Jamaica, you talked about the Congo. Like how quickly can these disposal sites be set up?
Yeah, those are just a few of the places that we've looked at and been in discussions with and that we've talked about over the past couple of months with you guys. But realistically it is scalable. Once we find, okay, this is the right tools for this process, this is the right tools for that process, then it's just a matter of putting the pieces together and getting them on a ship out there. So it is certainly doable, and we are actively making strides um, to get into some of those early markets to start waste reduction and to start monetizing. It's not just philanthropy. This whole project is very fiscally viable as well. To a lot of the times, you have to pay to dispose of tires. You have to pay to take things to the dump or take things to, recycling centers at times. This will allow that type of revenue to pay for the equipment to allow the generation process, the digestion process to go to these third world nations more efficiently and effectively and get to a point where it can help bolster and establish local economies.
Yeah. John, you have a question?
I do, people look at recyclable energy, renewable energy, or even a gas flare as free energy, but it's not
Mhm.
really free. Can you talk
Right.
a little bit about how much does free energy cost? And when you're building a business model, like what should you expect and how can you build that out?
Yeah, that's a great question. So, how much does free energy cost is a great way to put it. What your costs with something like this are going to be is your generator. Are you buying it outright? Are you financing it? What's your maintenance contract on your generator? We're looking at a lot of 1 megawatt generators from a major manufacturer, and the maintenance contract is something like a little over a half a penny a kilowatt for covered maintenance. Professional, the staff of the manufacturer comes in and takes care of everything. That's phenomenal. Very, very low costs for that ongoing maintenance and support for something like that. So if you can get good, efficient equipment with that kind of maintenance contract, and you have the capital to build up the facility, whether that be in a loan or a grant, or you reach into your pocket and make it happen, then you get to a point where you can have hyper low cost energy creation. Like theoretically possible, if you had the capital to bankroll everything yourself, you could be sub penny kilowatt consumption with your ongoing costs covered. Depending on the scale you go up to and how many staff you need to run, say, a Bitcoin mine, that may adapt that around a couple percentage as well. But it's absolutely incredible what you can do. And the other factor is a lot of the times, as I mentioned, people pay to get rid of tires and garbage. It's called a tipping fee. So usually for a residential like consumer grade car or SUV tire, your $1 to $5 is your tipping fee to get rid of that tire. That would be money that theoretically your recycling center would be taking in as revenue. So you're being paid to take your feedstock, to process your feedstock, to turn it into fuel, to run your generators, to monetize your electricity.
You're muted, John.
Yeah.
The possibilities of it are amazing of what can be done with having that life cycle because it's right now we're basically paying somebody to take our tires off of our car and then they just take them and they put them in a dump, they put them in a pile,
Mhm.
and so you're solving that huge problem. And uh you know Bitcoin is like a catalyst of the mother of invention to solve some of these problems because we need the energy, and there's all kinds of free and great energy resources and possibilities out there.
Right.
Is there a way to do this on a smaller scale? Like, you remember Back to the Future, they had the Mr. Fusion 3000 on the back of the
Right.
DeLorean. Like, is that in the future? What are we looking at?
Small scale operations is possible. In fact, a couple weeks ago when we were doing some of the testing, experimenting with some different options, we actually bought some crock pots. And thankfully, the store did not call Homeland Security on us because we were walking out all these crock pots and talking about experiments we're doing and pressures and things like that. But um, in the shop there, we were testing different catalysts and the viscosities of them in crock pots and putting material in and watching it react through the glass top, and it was really cool. It was cool stuff. So are you going to get a lot of yield from something like that? No. Would it economically be worth it for the home user to jerry rig their own machine? Probably not, but there are there are ways to get the size down, and with things like the plastics processing, we are working on different form factors for that, where theoretically you could fit it in a shipping container. And if we could get a processing plant in a shipping container, that's pretty effective in my opinion, as far as being able to work in a small or remote or third world operation.
Yeah, modularize the entire system and, ship, hundreds if not thousands of these units all over the world,
Right.
and be able to generate power or create Bitcoin depending on whatever situation you need. Now, I'm curious, do you have any data regarding, like, let's go back to like the feedstock for the tires. Do you have any
Mhm.
data on the tonnage of feedstock that you need to produce like so many kilowatts of energy?
Not specifically at this time. And that's because the feedstocks will react a little bit differently. Race car tires are different from residential tires, are different from, industrial or commercial trucking tires. So we have not been able to definitively identify X pounds of tires means X amount of material output, but the yields have been pretty impressive with what we've been testing and putting in place. So I'm sure in the future, as we build multiple facilities, as we have a facility up and running that can do 24/7 operations with staff going, that we'll be able to aggregate and get some better averages. But currently in our prototype reactor and our test scale, we can't definitively say exactly what output or yield would be because of the variable factors that we're working through as we build this process.
Yeah, that makes sense. I mean, you need more time to get more data, and like you said, it's not a one size fits all solution. There are different types of rubber compounds, so I completely understand. But I'm looking forward to seeing more of this data as it comes out, as you have more time to populate that data.
Yeah.
Have so I think about this video that I saw. I think it was about a year ago, and I can't remember who shared it, but it was this video of this island out in, the South Pacific or something like that. It's just covered in tires, and there's just
Mhm.
black smoke just pluming off of this island because they're burning the
Right.
tires, trying to get rid of it. Are you working like on partnerships with local governments or other industries to expand this model? Like, because like my thought is like if you could put these modularized systems on this island per se, you would have almost unlimited feedstock to be
Right.
able to recycle those tires instead of burning them and putting those harmful gases back into the atmosphere.
Yeah, absolutely. So we are in talks with many governments, both at the national level in other countries as well as some in the local and state levels within the U.S. We've talked a bit about international partnerships, but it's not solely going to be something done in third world countries. We are planning on implementing multiple sites throughout the U.S. and we're talking with officials to do that, and we're getting some support from entities that are wanting to move forward with projects like this. So we are, I would say, we're getting pretty close to the final stages of buttoning up the prototype ideas phase and the provability phase. We've run it, we've shown it. You guys have, John, you've been out there and seen it. It's absolutely incredible tech, and some of our next phases are going to be capitalization to achieve implementation, and that's what we're gearing up for, and that's what we're really excited about.
So what does that look like once you start getting into implementation? How much of that can you talk about, and
Yeah,
what are your
so
plans for the future?
um, plans for the future. We're definitely building more prototype sites, um, research and development sites, so that we can, streamline. And the goal is to modularize it to a point where we can say, package A, package B, package C kind of situation. And when we're talking with a city or a country or region or something that says, hey, we have this problem, and maybe they don't have the problem. Maybe they're a crossroads between three major cities that do. Um, can set up a plant there and start bringing in your feedstock to do things like producing energy. And in the case of maybe some of these smaller, like African villages or things out in these third world countries, there are ample opportunities to generate power for the entire village for something like this and run Bitcoin miners to help monetize the excess. And with something as modular as running miners, if you get to a point where let's say there's a heat fronts coming through, so some ACs are cranked up, or they need some extra power usage. Unplug a couple of miners or ramp them down, and you're sending that extra power to the necessary grid, just like curtailment on a micro scale. So you're bringing in the feedstock, you're producing the energy on site, but you don't have to worry about overflowing your storage tanks because you've got the ability to crank up the generator and consume everything that's in place there. Or if you need more energy on the consumer side, you throttle down the miners. It's really a very symbiotic relationship.
Yeah, so I guess I got a fun question. Let's just
Okay.
say, let's just say you make a bunch of these things and they're all over the place. You can get them at Home Depot now or Home
Okay.
Depot, Uganda, whatever. So Trevor's gonna meet us at the studio because we're gonna have to cover an hour.
Yeah, we
So,
got power back again. So I'm gonna head out. Thank you, Dan, so much. I really
Okay.
appreciate the time. I will see you in a bit, John.
all right, sounds good. Okay, so you can get these at Home Depot, and if you can buy this at Home Depot, people are just going to throw some crazy stuff in those things. What are some other uses? I mean, you talked about plastic garbage, you talked about tire garbage.
Hmm.
What are some fun things that we could put in there, um, and not blow it up?
Uh, I don't know that I really want to talk too much about that. Um, there, if it gets to a point where it is consumer available over the shelf, that is something that would have to have extreme safety warnings on, because you put the wrong things in there, you can have problems. For example, I don't know, everyone's used PVC. Well, what is PVC? That's polyvinyl chloride. What happens if you start breaking the plastics out of there? You get chlorine gas. Not okay. So there are I don't know if I should have said that. So but there are some things that should not be put into these containers. So I don't know if we'll see um any time where consumers would be able to pick up a digester and just throw stuff into it, but there is a possibility that maybe someday down the line we could sell um, pellets or something that are pre-configured where nowadays there's technology out there where you would have to scan a QR code before something can go in, maybe a pelletized system that goes in, the system scans it before it would actually inject it. That's probably 20 years down the line for something at that micro scale. But the other areas that could be potentially viable is some kind of bio solution, bio stocks, maybe organic yard clippings or things like that. That would, I'm sure, need a lot of testing and different catalysts. And I don't know what or how that could work with the existing systems to create the propane, but that potentially could be used to create some kind of other heat-based energy source.
Hmm.
Um, but
Yeah,
that's a great question. I personally haven't thought of the what do we do to make it retail ready on the Home Depot shelf.
yeah. I'm thinking the Mr. Fusion 3000 was a great idea. And
Yeah.
he put like banana peels in a soda cup, and a pretty wide range of things. So we are, at least in the near future, that's not going to happen. And I could see where the problems are. But I think sharing the thing about PVC is good because
Yes.
it is plastic, and people might think, oh, it's plastic, let's just burn it. But I don't know what PVC stands for. And as soon as you said chloride, I was like, oh, yeah.
Yeah.
I know enough about science to know that that's going to be a bad thing
Right.
to burn. So there is going to need to be some regulation there. Um,
Yeah.
what do you see as other, we were talking about ingesting, taking
Mhm.
a lot of heat and a catalyst and turning rubber or plastic into a fuel source. What about some other alternative renewable energy sources that someone could use to operate a generator or just create electricity?
Yeah, there's a lot of that out there. There's a number of places that do, biofuels and cow farms that are doing methane capture and stuff like that, which is, oh, excuse me, very intriguing, but it's outside the realm of my expertise to speak super intelligently on. I've seen a lot of the stuff up there, and it's really impressive. So that's an option I would definitely recommend people continue to pursue. The main shortcoming I found with that is the volume of excrement to the power generation side is a very difficult metric to hit and maintain to have anything scalable and worth the time and the material cost to do so. I met, I think it was a year and a half ago, or maybe it was last summer. I think last summer I was up at the Merkel hydro facility that Bitmain runs with Merkel in Spokane, Washington. And we were up there going through the presentation on hydro mining and toured the facility. And one of the guys there was out of Canada, and they're doing a lot with wood gasification. So they're taking like scrap wood that isn't necessarily useful for other projects and putting it through their systems through gasification, and they're producing energy from it at small scales, and that's intriguing as well. So there's a lot of really smart creative people out there working on projects like this. I just happened to get the email across my desk with the coolest one on earth, so I jumped on it.
Yeah. Okay, there's the mute. Yeah, that is great. You do have a cool thing, and I like to push the envelope and say, what other ways can we use this? Because I think that there's always an opportunity that someone will see what you're doing and they'll say, "Oh, I could go over here," and it's not copying your technology or copying the idea. It's just you're
Mhm.
sparking a creativity that wasn't there before.
Right.
Yeah. So
It's
it's the 2 o'clock yawns. I got them too.
yeah,
So I got my third cup of coffee for the day.
yeah.
But
It
go ahead.
Yeah, I was gonna say it's a really intriguing process, and my goal is that as we build out, we're gonna have a research and development center. So more so than just our existing, quote unquote garage super secret test location, but a full-on enterprise scale research and development center. And we have ideas in mind for that. We've got a prospect location for that with state support. So I think getting something like that in place will allow us to see, okay, what else can, we do this to? What else has the base elements that are going to achieve this for us? And start doing some small scale testing.
Yeah, yeah, yeah. And are you into the micro mining at all? I know you work with a lot of the big miners,
Mhm.
but we started the day off talking about micro mining, and Trevor he's going to be back in the studio and we'll be able to see him, but he has like
Yeah,
every BitX ever made. He's got a
yeah.
start nine, he's got nodes all over the place. Um, where do you see possibilities and opportunities there as far as could somebody get some solar panels? Could
Mhm.
somebody make their own wind turbine? Does it make sense to even do that?
Yeah, absolutely. So that's something I've done quite a bit with as well. You know, as we mentioned earlier, I do operate ASIC plug, and that predominantly was founded as a direct to consumer mining equipment provider. And doing direct to consumer, you're looking at those lower wattage, lower power consumption units, things like the Nano 3 or a lot of the altcoin miners. So I've had people that have come to me and say, hey, I have excess solar. The power company is only giving me, 5 cents a kilowatt hour for the power that I send them. I have a surplus of 1600 watts. What should I get? So I was talking with a guy out in West Texas, and he's got solar and he's not an institutional miner at all. He was just referred over to me. And I believe we were looking at something like the AL2 when it came out, a lithium miner from Ice River. I think it was about a 500-watt machine. So looking at some of those, looking at some of the other, smaller scale stuff, and then that gives him the opportunity to better monetize his excess power than what the grid was paying him. And when you have a situation where you can tap into solar converters and charge controllers and put like little vertical access wind turbines on your roof in a windy area, that can get you a couple hundred watts. And a couple hundred watts is enough to run some micro miners. I've got everything from right on my desk under here, I've got a nerd miner that runs on 1 watt through a little USB. And then I've got the Nano 3s, which are about 300 and 360 watts or so on 4 terahash. And Avalon just came out with the mini threes, the 37 terahash units for pretty low power supply. So there's a lot of options for home miners these days, even if you want to stick with Bitcoin versus the altcoins. So if you're a Bitcoin maxi, the Avalon Q is coming out. I think that's a 90 terahash. I want to say 1600-watt unit. So it's not hyper efficient like a full ASIC, but when you're at home and you can put this little thing in the closet or near a window so it'll kind of exhaust some of the heat passively through the glass, that's a pretty impressive home hash rate. 90 terahash to plug into anywhere. That's
Yeah.
that's revolutionary.
That is revolutionary, and I think that's where the invention comes in. I think all of these, the like the alphas that you're talking about, or the D1s, or
Hmm.
and all these like mini altcoin, and the mini Bitcoin uh, units, they provide invention because right now, okay, there's a little bit of cooling off. Like people aren't super excited about this whole
Yeah,
Bitcoin thing. Um, because it's taken a tumble like everything else is. But when it hits 105, everyone's like, "Oh, I got to heat my pool with it, and I got to do all these
right.
things." And these little miners give us the opportunity to do this. I think it's so cool that BitX made a mini immersion because I think all the other companies are going to follow suit with all these 500-watt, 1600-watt solutions coming up with like little mini immersion things. Like, how cool would that be to have a 500-watt gizmo that's immersion, and
Yeah.
you're doing some heat recycling with it. I mean, you could heat your fish tank or something. I don't know,
Hmm.
cook the little fishes. But there's lots of fun things that you could do, and all these things are going to just really spark and spawn invention. So it's going to be fantastic.
Yeah, I'm really excited to see that come out. I'm excited to see Bulk Miner release their hydro miners. I'd like to see more miners with water blocks integrated. I've got an AlphaPex DG1 Home in my server room here, and it uses a water cooling loop that's all internal. So it is fan cooled, but you're getting 2.2 gigahash of script mining, but you're not hearing fans spinning that you typically would for a 620-watt machine because it's got a water cooling loop, and then it cools the radiator just like an AIO for like a gaming computer would.
Yeah.
So it's almost silent, and you're getting that hash rate from there, and it's an awesome situation.
Yeah, I'm gonna do. I'm dedicating like 2 or 3 hours just to micro miners, where I'm just gonna go to all of them and learn as much as I can about them. Because we will at Bitcoin Mining World, we're gonna start becoming a retailer for a lot of those.
Hmm.
I just think it's a great opportunity to just learn more and just align
Yeah.
ourselves with those companies.
Yeah. I
Dan,
talk with Scott from BitAxe pretty often. He's in a think tank group that I'm in. So yeah.
mhm. Yeah. Dan, thank you so much. This has been, hanging out with you is always fun. It's not just about that tuna salad that we get at that little restaurant,
Right.
that I still dream about. But it's about the innovation and like the cleverness. You looked over at Carla, she's like, yeah, that was a damn
That
good salad.
that's what I heard. Yeah. Yep. She's over there watching.
So yeah, thanks so much for being on the show. I know that you can't make it to the event in Fort Lauderdale, but
Mhm.
are you coming up to the one in Milwaukee?
Yes, yes. Coming up to
Yes.
CypherCon, we'll be speaking on the Bitcoin stage. Carla is going to be representing me at Disrupt and at the conference with you guys, the Mining Mafia conference, and then or the after party, and she will be coming with me to CypherCon as well. So
Yeah, CypherCon's going to be great. We're on home turf, so we're going to have an adventure.
okay,
On the Milwaukee downtown, and it's really cool because there's a lot of, I think it's fun because it's definitely not maxi. I mean, we have people who don't know anything about Bitcoin to, all the layers that we don't talk about in Bitcoin maxi events like this.
hmm
They're all around. And so there's a lot of interesting conversations that can be had and a lot of innovation. And they're hackers, so they just sit around and they hack stuff, and they think
right,
that's fun, and I think it's great because I'm fascinated by the skill and the talent and patience that it takes to do that.
absolutely, yeah,
Yep. All right, so we are going to jump off into the next webinar. Dan, thanks so much for being here, and we are
yeah,
going to see
absolutely.
you. We're going to see you soon.
All right, talk to you soon.
All
Bye.
right, take care.